Hello, this is Mrs. Huntley. This is Module 4, Linear Relationships. We are stepping out of the Eureka materials for a week or two, and we are going to be using the supplemental packet that has the front cover that says 8th grade curriculum, Linear Relationships. This is the first lesson out of that, and it's called Slope and Rate of Change. I know there's no space at the top that says EQ, but I do want you to add an essential question. So the essential questions, I should say, for this section of the teaching is what is slope and how do I determine the slope of a line? So actually we're going to answer slope pretty quickly here. Slope is the rate of change in a relationship. Okay, it's going to, we've got our two variables, our x and our y, and the rate at which they are changing is the slope of those two things. So the slope, or rate of change, is a ratio of the following. Change in the dependent variable, that's our y, divided by or over the change in the independent variable, that's our x. So change in y divided by or over change in x. So I'm just going to put this in parentheses. Change in y over change in x. Now this looks weird to me because we've got the lines for you to put the words in, and then there's this line here. This line in the middle is actually a fraction bar. So it is y over x, just like what we've been practicing when we were in the Eureka materials. Now, on a graph of a linear relationship, the slope describes the steepness of the line. How fast is it going up, or how fast is it coming down, or maybe it's flat and it's just staying the same. So that's what slope is going to describe, and it's in a picture form for us. So, types of slope. When we're reading a graph, we're going to read from left to right, just like we're reading words off of a page. When you're reading this, you're starting at the left and you're reading to the right. So when we're looking at a graph, we're going to start at the left over here, and we're going to trail our eyes across that y-axis to the right, and whatever line is on it, the direction in which it's going is going to tell us if it's positive or negative. Now, if it's going up and to the right as our eyes are going across, that's a positive slope. This one over here, as we're going across from left to right, if it's going down, it's a negative slope. Okay, if something is staying the same, it's flat. That's called a zero slope. And if it's vertical, straight up and down, it is an undefined slope. Now, I'm going to try to show you a video of something called Slope Dude, and I'm hoping it's going to work. I've never done this before on a video, so if it doesn't work, we'll find out very shortly, won't we? So let me try to show you Slope Dude really quick. Maybe. Maybe. Sorry.
As he finishes the flat part, he doesn't see well ahead, and all of a sudden he comes to the edge of a cliff. It's straight down. He finds a slope that's straight down, and so frightened is he that he says the worst curse word possible in math and algebra. Undefined. This has been the adventure of Slope. Remember always what he said during his ski trip.
Okay, so I know that's kind of goofy, but when he's going up the hill, it's puff, puff, positive. When he's coming down the hill, it's nice, negative. Just a different way of remembering it. When you're on the flat part, if anybody's ever done cross-country skiing, I'm not a fan. It's when you're in the flat part and you're working really hard, it's zero fun. Think about if you've never cross-country skied, maybe you've been on a, if you're tobogganing and you're on a flat part, you're not going very fast and it's going to be not very fun. And the vertical part, I like to say that if you ski off a mountain, your body at the bottom of the mountain is going to be undefined. Well, hopefully nobody's ever going to ski off of a mountain. So that was the Adventures of Slope Dude. I know, kind of goofy, but maybe a way that will help us to remember the different slopes. Okay, so hopefully you can hear me because I have not done a YouTube video in the middle of one of my recordings before, so I'm hoping everything's working out well and I won't know for a few minutes. Anyway, let's take a look at these examples here. So identify the slope of each line on the graph. So line A, this is that flat part where we said it was going to be zero fun, right? So this would be a zero slope. Line B, that's this one. So again, when I'm looking from left to right, it's going down. That's going to be a negative slope. Line C, oh, my cursor is not working. Line C is right here. This would be that cliff edge. If I ski off that, I'm going to be undefined. And line D is the last one. If I look at it from left to right, it is increasing, and if it's increasing, that is going to be a positive slope. It says list any strategies to help you remember the difference between a graph with an undefined and a zero slope. I do really like, I know Slope Dude is really hokey, but I really like the idea of the flat part being zero. You know, it's zero fun. If you are sledding or something like that and you have a flat area, it's not terribly fun to sled on a flat area unless somebody's pulling you, and then it's not fun for the person that's pulling you. Same thing with the vertical. If you're going down a vertical slope, it's pretty scary. So yeah, you're gonna, you might utter that curse word that Slope Dude was talking about, that undefined word. So let's move on. Okay. To find the value of a slope from a graph, you find the ratio of the vertical change compared to the ratio of the horizontal change. We call this rise over run. It's the change in y over the change in x. And sometimes you're going to see change represented by a delta, which looks almost like a triangle. I guess it is a triangle, isn't it? So delta y over delta x, or change in y over change in x. Now, when we have a graph, we can choose any 2 points on the graph line and draw a right triangle to count the rise and the run. Now, we did this before when we were doing Pythagorean theorem, and it's very, very similar. So this shouldn't be anything that's super difficult to figure out. So we're going to draw a right triangle, and we're going to simplify our ratio whenever possible. But if it's not possible to simplify it, we're going to leave it as a fraction, okay? We're going to check to see if it's a positive or a negative. Now, looking at this one over here, we're going up and to the right, so that's going to be a positive slope. So the rise of our graph from this point to this point, and what I'm doing is I'm counting, like if this were a road map again with our north-south and our east-west streets, I'm counting how many blocks I'm going up before I turn the corner and I go to the right. So I'm going up. Here's 1, 2, 3, 4. So my rise is 4, and then I turn the corner and my run is 1, 2, 3. So my slope of the graph is going to be 4 over 3, or 4/3. Now, I could make this into a mixed number, but when I'm counting slope, it's easier to leave it as an improper fraction because I know I'm going up 4 units and then to the right 3 units. Now, how do I choose the points that I'm going to use? I need to know where my north, south, and east, west are meeting, and I'm going to choose a point at an intersection. So this particular one, they drew a point. Whoops, I'm trying to get an eraser here. They drew the points for us. So I can count my rise from this point to this point. I'm going up 1 unit, and then to the right 1, 2, 3, 4 units. So my slope here is going to be 1 over 4. My vertical change is 1. My horizontal change is 4. Now on the next one, on number 3 right here, they don't have points on there. So we have to pick places where our lines are crossing, where the line that we're trying to figure out the slope of is crossing the intersection of two points on the coordinate grid. Now, the reason I'm not picking, I wouldn't pick this point, is because I don't know exactly what the y value would be there. It's somewhere between 5 and 6, but I don't know exactly what it is. So I want to pick where the line that I'm trying to determine the slope at is actually crossing the intersection of 2 points. So here I'm going down 1 and over 2. So it's going to be a negative slope, 1 over 2. Now I can look at the line too and determine that it's negative and then just count rise and run. So why don't you, if you're feeling comfortable with this, why don't you try to pause the video and pick out the points on the next graph to count between, okay? So I'm going to go ahead and do it with the recording going, but if you're feeling some level of comfort, I would go ahead and pause and see if you can figure it out without my assistance. Okay, what I just did is I made points at each intersection where my line is crossing a coordinate pair, an integer coordinate pair. Like if I were to label this one, it would be 2, 9. This is 2, 9, okay? If I'm to label like this one, this is 4, 18. It's where it's crossing that intersection of those 2 points. Now you don't have to add those lines on there. I just wanted to make sure you recognized why I was choosing the points that I'm choosing. Now you can pick any 2 points on a line. You don't have to pick the same points that I picked, but I just identified all of them on this particular line. So if I'm counting my rise, 1, 2, 3, my run is 1, 2. 3 over 2. Now say you counted between these two, I should get the same thing, 1, 2, 3 over 2. If I counted this one, same thing, 1, 2, 3 over 2. So anywhere on this line, I'm going to get the same slope. What if I didn't notice that that my line was crossing integer coordinates in between any of these other points, and I went from the origin here all the way up here to this one? Let's see what's going to happen here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my rise is 9. My run is 1, 2, 3, 4, 5, 6. 9 over 6. Okay, 9 over 6. I can reduce that fraction, right? Both my numerator and my denominator are divisible by 3. So this is equal to 3/2. So again, anywhere on this line, I can count slope, and it's going to be the same slope at every point on the line. Alrighty, let's move on. Number 5. Pick some points on number 5. and count the slope, I'm going to encourage you to pause the video right now. Okay, so I went up 4, to the right 1, 2, 3, so my slope is 4 over 3. Next one, hopefully you're looking at it and you're thinking about Slope Dude and sledding or skiing off the edge of a cliff and yelling undefined. And of course this last one, go ahead and pause the video. It is a negative slope, and I'm going down 1, right 1, so it's be 1 over 1, which would be a -1 slope. Okay, so if you have a whole number slope, that means it's over 1. And the steeper the line, the larger the number slope. So these are all fractions, so they're relatively flat lines. This one is the steepest of all of them because it's a whole number here. Alrighty, I believe that concludes the lesson for the video. And if, of course, bring any questions that you might have to class tomorrow, and I will address them then, and we will be practicing with this all week. So if it's not making sense to you, don't worry, it will soon.